Professor Bialis here. In this video, we're going to be talking about section 8.2. There's going to be two parts to this. We're going to talk about just a general review of function notation, and then we're going to start graphing nonlinear functions. We're not going to get into much detail with it. We're going to keep it very simple, but we're just introducing that idea in this video. So first thing we're going to do is review function notation. So I already have a graph up here on the board. We'll talk about how to generate that graph later in this video. Okay, but right now I just want you to think of this graph as a function f of x. Okay, now what I'm going to ask you is to read information off of this graph. Seems simple enough, and it is, as long as you know how things are written and how to interpret what is given to you. So first thing they're going to say is something like this: find f of 2. Okay, now remember, it's f of x. That number that's within those parentheses will always be your x coordinate. That is your input value. What they're asking for is, when the x is 2, what is the y value? Remember, f of x is a fancy way of writing y. So if I go to an x value of 2, I have a point that goes to a y value of 1, 2 comma 1. So all I would say is, when f is 2, or when x is 2, the f, or the y value, is 1. Okay? Let's say I have f of negative 4. Okay, so if I go to negative 1, 2, 3, 4, what kind of y value do I have? I have a y value of 2. Okay? Now, if you notice, let's say I said f of 1, I would be somewhere in between there. This one's pretty straightforward because it's just you're running 2 and rising 1. But if you have to, you would just approximate. That's really the only way to do it, just given a graph like this. Okay. Usually, though, they're going to ask you numbers and values that are clear to see. How about we go with something like this? Let's say we have f of x equaling 2. Okay. Now, what they're asking here is a little different. They're saying that the x value is unknown, but the y value is a 2. If the y value is a 2, that brings us to this level right here. Now, we're asked what x value or values hold that height, that y value. So if I go over here, I see an x value, and if I go over here, I see this x value. So what I would do is I would get this 4 and that negative 4. So in this case, f of x equals 2 is when x equals 4 and when x equals negative 4. Okay? Now what if I asked for f of x equals negative 3? Okay, so what x value has a y value that's negative 3? If I go on the y-axis to a negative 3, notice there is no graph down here. Okay, so in this case, I would just say none. Okay, there is no x value for that. Don't say 0, because 0 is an input value. Okay, and that wouldn't be appropriate for the negative 3. So clearly say none exist. Okay, so that's pretty much it for the function notation part. Before we get into the graphing part, there is one other thing I want to point out. And we'll look at this in much more detail when we get into chapter 10. But really quick, let's talk about square roots, because they're going to play a role in these graphs in a minute. So just real quick, if I said square root of 9, okay, I want you to all understand what that is telling you to do. What's that asking you to do? You're asked, what do I square to get a 9? Okay, and all we're looking for is what's called the principal square root, and it would just be a 3. That's it. Okay, you may be thinking, well, if I square a negative 3, technically that gives me a positive 9 as well. And that's true, but again, all we're looking for here is what's called the principal square root, so just the positive value. Let's say I have square root of 1/4. Okay, don't overthink that. Yes, it's a 1/4, but I'm looking at it as a 1 and then a 4. So square root of 1 is 1, square root of 4 is 2. Nothing more to it than that. Now, there are numbers like this that don't come out nicely. That exists. Okay, square root of 3 is a value, but it's an irrational value. Okay, it's not something that we're going to be seeking out, especially when we get into graphing, because we want to approximate as little as possible. Okay, so numbers like this do exist, but when we get into the graphing today, we're going to try and force values that work out nicely like these. Okay, so let's look at the graphing portion of this section. Now, there are three main nonlinear graphs that they are going to be talking about here. The first one is going to be what we would call a quadratic, okay, or you could just call it the square function, okay. Now, to get the basic shape of this graph, let's just plug in some values, okay, and that's pretty much how we're going to be graphing in this section. So if we're taking this x squared function, whatever input I plug in here, all I do to get the output is square it. Nothing more than that. So if I take 0 squared, I stay at 0. If I go to 1 and I square it, 1 squared is 1, so I go up 1. I go over to 2. 2 squared is 4, so 2, 4. If I go to 3, 3 squared is 2, 4, 6, 8, 9. And there we go. Okay. If I go to the other side, negative 1 squared is 1. Negative 2 squared is 4. Negative 3 squared is 9. Now, I could keep going if I wanted to, but on the graphs that we're going to be working with, this will be sufficient. Okay, so what I'm going to then do is connect these dots, and I don't have a straight line here, I have a curve. Okay, and that curve is called a parabola. Now, we will talk more in depth about graphing these in the future, but all I want you to understand right now is when I have a function with an x squared in it, I should expect a U shape. Nothing more than that, okay? Now, let's look at a more general example with this quadratic. Let's say I have f of x equals x plus 3 squared minus 2. Okay? Now, the fact that you have this square here tells you I should be expecting a U shape on my graph. Okay? When we get into chapter 11, we are going to talk about this in more detail to just be able to interpret what we see, and boom, we get our graph. But before that, right now, we are just going to be using a table of values. So I'm going to create a table. I'm going to plug in a bunch of x values, and then I'm going to calculate that x plus 3 squared minus 2 to pop out my y values. Okay? So, which x values do we pick? That's up to you. Okay? But pick enough so that you end up with this U shape. Do not stop until you see the U shape. So, if I'm going to go with, let's say, 0, 1, and 2. Let's just see what happens with that. Okay? I'm going to plug them in. And see what I get. So I've got 0 plus 3 is 3, 3 squared is 9, 9 minus 2 is 7. 1 plus 3 is 4, 4 squared is 16, 16 minus 2 is 14. 2 plus 3 is 5, 5 squared is 25, 25 minus 2 is 23. Okay? Let's plot those and see what we get. We get 0, 7. So 0 and then 2, 4, 6, 7. And then we have 1, and we're up at 7, and then 2, 4, 6, 7. And then that last one, 2 comma 23, that's way off my graph. It's not wrong, but it's not useful to me, okay? Now, as you can see, I don't clearly see a U shape forming. The biggest mistake I see students make is that they connect these and they just say, okay, I'm just going to bounce right there. We don't know if that's going to happen. Maybe that bounce happens over here somewhere or over here somewhere, okay? So we need to see it exactly where it belongs. So I need to pick some more values. Now I have to make a decision. Do I want to go with a 3, a 4, and a 5? Or do I want to maybe go with a -1, -2, -3? Okay? If I go 3, 4, 5, look at what happened with these values. They just got bigger and bigger and bigger. Okay? So let's go the opposite direction. Let's go with a -1, -2, -3 and see what that does. So plug them in. And see how they calculate out. -1 plus 3 is 2. 2 squared is 4. 4 minus 2 is 2. -2 plus 3 is 1. 1 squared is 1. 1 minus 2 is -1. -3 plus 3 is 0. 0 squared is 0. 0 minus 2 is -2. Let's see what happens. We've got -1 comma 2. We've got -2, -1. We've got -3, -2. Do I have that U shape forming yet? Not quite. Okay, but you can see that my curve is flattening a little bit. So it looks like we're going in the right direction, but we need to go a little bit further. Let's say -4, -5. Okay, -4 plus 3, -5 plus 3. Okay, so -1 squared is 1. 1 minus 2 is -1. Now, do you notice I already have that y value? Okay, that is going to show a bounce back up. Let's do one more though, just to make sure. -5 plus 3 is -2. -2 squared is 4. 4 minus 2 is 2. Okay, so notice we repeat here, we repeat here. Okay, that's a good sign. Let's see how that looks on the graph though. We had -4, -1, and then -5, comma 2. And now we can clearly see that U shape forming. Okay, so let's connect the dots. And there we go. Okay, could we get more points? Absolutely, but at the very least do this. Okay, that's all I'm going to be looking for when you do these graphs. Now notice that took quite a few points. If you get lucky and you pick 3 values that show a U shape right away, that's fine. Okay, but at least 3. You're going to need to have at least 3 to get that shape formed on your graph. Okay, so that is a square function. Let's look at a different one. Let's say we have an absolute value function. Okay. Now, what's the general shape that that's going to have? Okay. If we're not sure, then let's dig in. If I take the absolute value of all these x's, I get the y value. So absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. 3 is 3. 4 is 4, 5 is 5, 6 is 6, 7 is 7. Go the other way. Absolute value of -1 is 1. Absolute value of -2 is 2. -3 is 3. -4 is 4. And then look at what we get. We get a V shape to our graph. It's very similar to that quadratic or that square function, but it's a sharp V shape. Okay? So, when we deal with these absolute value functions, we should be expecting a V shape. Okay? And we plot points until we get that V shape. Okay? So, let's look at a more general example. Let's say we have f of x equals, let's say, absolute value of x minus 4 and plus 2. Let's say that. Okay? So I got to start somewhere. So I'm making a table of values. Fill this in. And let's see what we get. I'm going to start simple. Let's say 0, 1, and 2. Okay? So if I plug those in, let's see what we get. Okay? That first one, 0 minus 4 is negative 4. Absolute value of negative 4 is positive 4. 4 plus 2 is 6. 1 minus 4 is negative 3. Absolute value of negative 3 is positive 3. 3 plus 2 is 5. 2 minus 4 is negative 2. Absolute value is positive 2. 2 plus 2 is 4. Let's see what we get. We've got 0, 6. 0, 2, 4, 6. We've got 1, 5. We've got 2, 4. Do we have that V shape yet? No. Again, I see a lot of students, they're like, okay, well, I'm just going to bounce back up here. We don't know that. Okay, maybe that V shape is here, or maybe it's down here somewhere. We don't know. Okay, but I think it is safe to say that we need to go further this way. Okay, the other thing is, when did that V shape occur? That V shape occurred when we went from positives and switched over to negatives. Keep that in mind. Okay, now negatives aren't necessarily the negatives we're plugging in, but the negatives we're getting out of the calculation. Okay, so let's look at this. I'm going to keep going with 3, 4, and 5. Okay, let's plug that in. We've got 3 minus 4, 4 minus 4, and 5 minus 4. Okay, so we have 3 minus 4 is a negative 1. I didn't plug in a negative, but there's a negative in the calculation. Absolute value of negative 1 is 1. 1 plus 2 is 3. 4 minus 4 is 0. Absolute value of 0 is still 0. 0 plus 2 is 2. 5 minus 4 is 1. Now that's a different thing. Okay? Up until this point, we've always gotten negatives, and then we got a 0, and now we have a positive. So let's see how this plays out. 5 minus 4 is 1. Absolute value is 1. 1 plus 2 is 3. And you see that repetition in the y values. Okay, that means whatever level we hit before, we're coming back up to that same level. Let's see how that plays out. We had, what was it, 3, 3. We have 4, 2. We have 5, 3. And that shows us our V shape. Again, if you wanted more points, you can. For our purposes here, I'm okay with that. And there's our V shape. Okay? So the bottom line is, you are just plugging in points. But plug in enough points till you see what you are expecting. I want you to come to the table expecting, when I see an x squared, I get a u. When I see an absolute value, I get a v. You need to have that in your head. Okay? After that, it's just kind of searching and exploring for that bounce effect in the graph. Okay? There's one more I want to talk about that's going to work a little differently than this. So let's see what that looks like. Let's say we have what's called a square root function, like so. Okay? Now, when we're dealing with square roots, I'm going to go ahead and just plug in to see what kind of shape I should be expecting. Okay? Now, if I start at 0, what's the square root of 0? Square root of 0 is 0. I go to 1, square root of 1 is 1. I go to 2, square root of 2. Now, square root of 2 is one of those irrational numbers. It exists, but I don't want to have to graph that. So let's seek out nice values. So square root of 1 was 1. Square root of 2, not nice. Square root of 3, not nice. Square root of 4 is 2. What's the next nice square root? The next nice square root is going to be 9. Square root of 9 is 3. If I want to keep going, I could say square root of 16. Typically, the graph grids that you're going to be working with are not going to reach out to 16. Okay, so this is enough. What happens is we get this kind of a curve. Okay, now I started with 0. What about these negatives? Now think about it. Can I take a square root of any of these negatives? No. Okay, I can't square, I can't multiply a number by itself and get a negative value. When that happens, I have what's called an imaginary number. We will talk about that at the end of chapter 10. Okay, but right now we're not working with that. This is a real number plane. So all these negatives aren't going to be in play. So what we have is a distinct point of origin, and then it goes up and over. So that's what we should be expecting out of these square root functions. Something like that. Now it is possible to get this graph to go this way, or to go this way, or to go this way, but right now we're not going to dig too deep into those alternatives. Okay, we're going to keep things pretty simple. Now, how do we get this graph going? Let's say we have something like this. Now, just to be clear, this minus 3 happens after the square root. Okay, so we have that square root of x minus 5, then we subtract a 3. Now, when we go into our table, move this over a little bit. We have to be a little bit more careful with what we use for x. Okay? Not that we would pick a number that was wrong and we wouldn't see that it's wrong. It's just going to be very easy to pick a value that doesn't really help us. Again, we want to avoid those numbers that are negative, number one, and number two, the numbers that don't come out nicely with the square root. Okay? So if I just go with 0, 1, and 2, for instance, just look at how that plays out. If I go 0, 1, and 2, if I plug a 0, 0 minus 5 is negative 5. I can't use that. 1 minus 5, negative 4. I can't use that. 2 minus 5 is negative 3. I can't use that. Okay, so it's very easy to get values that just aren't going to be usable. So what we need to do is be a little bit more thoughtful in what we use. Okay, now remember back in this original graph that I had on there, let me throw this up here real quick. We had this. Now, what points did we pick? We picked an x value of 0, because the square root of 0 was nice, x value of 1, x value of 4, x value of 9. That's what we should be targeting in any square root function. Okay? So what I'm going to do is I am not going to be plugging in 0, 1, 4, and 9. Because if I plug in a 0, 0 minus 5 is negative 5. That's still no good. But I want to make a synthetic 0, 1, 4, and 9. Let me show you what I mean by that. I'm going to be targeting a 0, a 1, a 4, and a 9. Now, where do I get those from? I am going to take the radicand. That's the expression underneath the radical. And I'm going to set that equal to 0, 1, 4, and 9. Okay, so x minus 5 equals 0. X minus 5 equals 1. Whoops. X minus 5 equals 4, and x minus 5 equals 9. Okay? So again, what I'm doing generally is taking that expression under the radical and I'm setting it equal to 0, 1, 4, 9. If I solve these, I just add a 5 every time. So I get x equals 5, x equals 6, x equals 9, x equals 14. Okay? So what I'm actually plugging in is a 5, is a 6, is a 9, is a 14. Okay? Let's see how those play out. So instead of just randomly picking values, I am targeting 0, 1, 4, and 9. I set the radicand equal to each of those, and now I get x values that are going to work out nicely. Okay, now look at what happens. 5 minus 5 is what? There's your 0. There's your synthetic 0. So square root of 0 is 0, minus 3 is negative 3. If I plug in a 6, 6 minus 5 is 1. That's a synthetic 1. So square root of 1 is 1, minus 3 is negative 2. 9 minus 5 is 4. Square root of 4 is 2. 2 minus 3 is negative 1. 14 minus 5 is 9. Square root of 9, 3. 3 minus 3, 0. So don't just randomly pick values when you have a square root. I always target these 4 values. You need to remember 0, 1, 4, and 9. They're just the perfect squares. They're not just random numbers. They're perfect squares. I set the radicand, whatever's underneath here, whatever it is, set it equal to those, and then that tells you what to plug in for x. And then that should work out nicely for you every single time. So now when I graph that, I get 5, negative 3. I get 6, negative 2. I get 2, 4, 6, 8, 9, negative 1. And then this was 9, so then I go 10, 11, 12, 13, 14, 0. And now I have that same up and over shape placed in the correct spot. Okay? So it's very important that you use these as targets to start when you have a square root function. Because if you don't and you just randomly pick them, you may eventually stumble into numbers you could use, but you might be missing this one. And that's not a complete graph. Okay, that's the biggest mistake I tend to see people make, is that if they just randomly pick values, they get enough to get that up and over, but maybe they miss that point of origin. This way you will always get the numbers that you need to get a complete graph. Okay? So, other than that, that's pretty much it. So again, what you need to look at is that function notation from reading it off of a graph. That's what we started with. They did a quick kind of introduction to radicals so that we were prepared for this. Okay? And then we talk about that graphing nonlinear functions. It's going to be one of these 3. If you see a square in the original function, aim for that U shape. Absolute value, aim for that V shape. And then if you have that square root, don't really aim for any kind of shape. Aim for these numbers. Okay? Other than that, again, this is a practice of patience, especially with the U and the V. Make sure that you are just taking your time and you keep digging in until you find what you're looking for. Okay? As always, work hard. Let me know if you have any questions, and I'll see you next time.